Hi, I'm David Andine, Director of Reference Designs here at Maxim Integrated. And today I'm joined by Sydney Chan, Senior Business Manager in our Industrial Power Business Unit. Sydney, thanks for joining me today.
Thanks for having me here, Dave.
So Sydney, today we're here to talk about power modules.
That's right.
And let's start by talking about what are some of the reasons that engineers would design in power modules versus something like a discrete DC to DC switcher or something in the middle like a DC to DC switcher with integrated FETs.
If you can imagine, every system needs regulated power, right? But to design a proper power supply and make sure it's working properly, it takes time, it takes good design expertise, right? So with these off-the-shelf turnkey type power module solutions, system designers can essentially focus more on their core design rather than trying to design the power supply itself.
Sounds pretty great. What's the catch? What are the drawbacks from necessarily using a power module then?
I mean, one of them is that some power modules out there, they only integrate the inductor together with the switching regulator and integrated FET and basically call it a day. So that leaves the system designer to still design the compensation as well as all the supporting passive components around it, right? That almost defeats the purpose of having an easy to use power module to begin with. The second thing is really the compromise on performance. Some of these modules out there, they are not very efficient compared to the discrete designs you mentioned, or if they do, they really are much bigger or are much costlier than those designs. But I would say the single biggest roadblock to power modules is cost. Today, vendors, customers, they feel really trapped by the fact that if they design a power module solution, they're stuck with it, right? So it's really hard for them to migrate to a lower cost solution without completely scrapping their design and starting from scratch.
Right. Now let's talk about the modules from Maxim. What are some of the things that we're doing to address these issues with power modules?
All right, yeah, why don't I just show you actually. So here's one of Maxim's power modules. What you're holding in your hand there is a 60 volt, 3.5 amp capable power module. What do you notice about it, Dave?
Wow, it's super small. I mean, it just looks like a regular semiconductor.
That's exactly right. These system and package modules integrate everything you need inside the module for a complete power supply solution. We started off from your discrete PWM controller ICs, right, with all the external components and all the external FETs and the inductor. Then you have your switching regulators, right, with integrated FET, which are a smaller solution. But with these power modules, they're kind of like as easy as you can get with a power supply solution because they integrate everything that's necessary to form that supply. And all you need in the end is an input capacitor, output capacitor, and maybe 2 resistors to set the output voltage. And to show you, I actually have an actual EV kit that shows exactly that. I mean, what you're holding in your hands there is a complete power supply solution.
Wow, that's just incredibly small for a complete power supply solution. Now you mentioned compromises in performance. What kind of performance can customers expect out of the Maxim power supply modules?
Yeah. Instead of talking about it, I'd rather just show you, in fact.
Great.
So we have a small setup right here. It's actually a demonstration platform with various power modules from Maxim. And we have it connected to a USB oscilloscope and a computer with a software GUI interface to just show you real time versus stepping into the lab. But as you can see here, we have the Maxim 17503 part that you were just holding, right? And say for example you want to run it at 60% load, right, for a 24 volt input nominal voltage, right? You can see here in real time what the efficiency would be. As you can see, it's more than 90% efficiency. So the performance is something we haven't compromised on.
Wow, that's impressive. Are there any other types of benefits that customers can expect from using a Maxim power supply module?
Inside of these modules, Maxim uses our Himalaya IC technology. So Himalaya is a name that we use to refer to our lowest power dissipation and smallest switching regulator technology with integrated FETs, right? So with these parts, they represent the industry's highest efficiency parts.
So what other differentiators or benefits can customers expect when they use Maxim power supply modules?
Yeah, well, we started off talking about how power modules should inherently make it easier for the system designers, right? Well, why is it then that a power supply designer has to just start from scratch every time their power supply requirements change throughout a project, right? It's ridiculous. So these Himalaya modules, they've been designed from the ground up to be pin-to-pin compatible, meaning that, across different input voltages and across different current capabilities, a customer can simply just swap out different modules to achieve their design.
Very, very nice feature. So Sydney, let's get back to the big question, which is cost. What kind of value proposition can customers expect from Maxim power supply modules?
It's not just the unit cost itself of these parts, but it's really the total cost of ownership, right? So what we've done with these Himalaya modules is we've really, made sure that it simplifies the entire supply chain. Because we integrate so many different components inside of it, we make it simpler for the end customer so that their procurement team or component engineer doesn't have to manage all those things. And as part of that, in that same theme, Dave, Maxim is the first vendor to enable customers a cost reduction path for moving from modules to ICs. For example, if a customer wants to start with modules for fast prototyping or fast time to market, they can start with the modules and then move to the equivalent ICs for lower costs, to realize lower costs and or optimize performance. And that's possible because we reveal exactly which ICs are used inside of these modules. Overall, with the Himalaya modules, it's really changing the notion of what modules should be and what it's capable of.
Well, Sydney, undoubtedly, these power supply modules are disruptive in the market, and I want to thank you for joining me today to talk about them.
Definitely.
And thank you for joining us today. For more information, please visit the Maxim website at www.maximintegrated.com/power modules. And keep in mind that all of the modules that we've talked about today are readily available for use in your design immediately. Thanks.